In this video, we'll get an overview of Cuba command line interface. In a nutshell, Cuba CLI is a command line utility that allows you to easily create projects based on Cuba platform. Also, it provides a lightweight scaffolding of the main project artifacts, entities, screens, services, and so on. With this tool, you can use the Cuba platform without any additional proprietary tools. I will show you how to create a simple application for customers and orders management using only a command line and a Java IDE. Open a terminal and run the Cuba CLI command to start Cuba CLI. To create a new application, input the command create app. You can use tab auto-completion. CLI will ask you about the project. If a question implies the default answer, you can press enter to accept it. You will be asked the following questions. Project name. For sample projects, CLI generates random names that can be selected by default. Project namespace. The namespace which will be used as a prefix for entity names and database tables. The namespace can consist only of Latin letters and should be as short as possible. Root package is the root package of Java classes. Platform version. The platform artifacts of the selected version will be automatically downloaded from the repository on project build. Database. The SQL database to use. Choose HSQL. An empty project will be created in a new folder in the current directory. Close CLI or open a new terminal tab and navigate to the project folder. Run Gradle assemble. At this stage, all the required libraries will be downloaded and CLI will build project artifacts in the build subfolders of the project folder. Run Gradle start DB to start the local HyperSQL server. Then run Gradle create DB to create the database instance. Run Gradle setup Tomcat deploy start. The Tomcat server with the application will be deployed in the deploy subfolder of the project. Open the web browser and proceed to the default application URL. The username and password are admin. They are filled in by default. The running out-of-the-box application contains two main menu items: administration and help, as well as the functionality for security and administration. In order to develop business logic, Cuba provides the integration plugin for Java IDE. Open IntelliJ IDEA and install the Cuba Framework Integration plugin. This plugin provides navigation between screen descriptor, controller and data model components, advanced injections, including screen components, actions, services, data sources, Cuba infrastructure beans and services, Cuba-specific code generation and refactoring, hot deploy of individual source code files, and simple localized messages creation and selection in components. To import the project into IDE, run Gradle IDEA and then open the IPR file. Let's create a data model and a graphic interface for our simple Cuba-based application for customers and orders management. The order entity should have a many-to-one relationship to customer. Let's start with creating a customer class. Enter entity in a terminal. You will be asked to enter the entity class name, customer, and select the entity class package name, accept default. Entity may be persistent embedded, or not persistent. Choose persistent to make the entity able to be saved in the database. Let's add some fields. Open the created class in your IDE, add the name and email fields, both of string type. Cuba platform supports localization in the same way as other Java applications, by using message properties files. Let's add messages for the new attributes. Create getters and setters for them. Once all the attributes are created, we will set the name pattern to get a meaningful customer instance representation in the UI. CubeCLI generates dbScript stubs for created entities, but the custom fields should be added manually. So add name and email both to db initialization and update scripts. Run Gradle update db to create the table for the customer entity. Now let's add the user interface for the application. CubeCLI can generate the standard CRUD screens using two predefined screen templates, browser screen and editor screen. The browser is a screen for viewing all records from a database. It includes data filter and supports paging by default. The editor is a screen for viewing or editing an individual record. Enter Screen Browse and accept the defaults to create the browse screen for the customer entity. Enter Screen Edit and repeat the steps to create the edit screen for the customer entity. The screens have been created in the web module package. Let's customize them a little, adding name and email fields to the browse table and editor field group. Let's create the order entity now. Add the following attributes: date, the order date, amount, the order amount of big decimal type, and customer, the many-to-one reference to the customer entity. At this stage, we can already define how exactly we want to choose a customer in the UI when we create an order. Let it be a drop-down list with a lookup action and the ability to open the selected customer in a new window. Don't forget to define the messages and to add the new attributes to dbScripts. Now let's add two more entities, order line and product. So the order will contain a set of order lines which refer to some product. Furthermore, we will implement order amount calculation based on the quantity and price of the selected products. So we create the product entity and define its attributes. Name, which is a string, and price, which is a big decimal. Both attributes are mandatory. Now let's create the order line entity. Add the following attributes: order, which is a many-to-one reference to the order, product, which is a many-to-one reference to the product, And finally, the quantity, which is a big decimal attribute that sets the product quantity for a given order line. Add the collection of lines for the order. Create the lines attribute, which is a composition reference to the order line entity. That means that the order lines are created and edited only alongside the original order. The corresponding attribute on the reverse side of the relationship is defined with the mapped_by attribute. Additionally, for the database integrity, you can define database constraints, but this part is out of scope now. Run Gradle update DB to create tables for the new entities. Time to create the UI. At first, create the standard screens for the product. After that, create the UI for order line. The list of order lines should be displayed in the order editor only, so we don't need an order line browser. Since the order line entity includes the reference attribute product, we have to create an entity view that includes this attribute. A view, in Cuba terms, is a declarative way to specify which data should be extracted from a database. Now we can display products in the order line editor. Let's create the standard screens for the order. The order entity contains two reference attributes, customer and lines. Suppose we would like to display customers in the browse screen and the complete graph of entities in the order editor. In this case, we need two separate views. Now we can add all necessary fields to order screens. We will also make the customer editor display the list of orders. Open the customer edit XML file and create a new data source for loading the linked order instances. You can use Cuba plugin autocomplete function. All the screens are done now. Start the application server and make sure they're functional. We still have to implement the order amount calculations based on the product price and quantity. Switch to the Java controller of the order editor. To begin with, let's inject the link to the LinesDS data source into the controller class. Now, add a listener to the data source in the init method using a lambda expression as the implementation. The lambda expression will call the new calculateAmount method. Having finished here, we can perform hot deploy and see the changes simply by switching to the web browser and reopening the order editor, without stopping the application server. As we can see, the order amount corresponds to the order lines, and if you modify them, the amount is recalculated. Our application is done at the first approximation, and all that we used is Cuba command line interface and Java IDE. Thank you for your attention.